What's up, summarized science viewers? In cybersecurity, detecting a hacker is a frantic race against the clock, but modern security systems have a big weakness. They analyze all the actions happening on a computer, which they model as a provenance graph, essentially a giant web connecting programs to files and network activities. Specialized AI called graph neural networks are great at finding suspicious patterns in this web. The problem, as you can see in this graph, is that computer activity isn't steady. It's incredibly bursty. Traditional security systems are like having a fixed number of security guards. When a massive, unexpected crowd shows up, they get overwhelmed. This means detection slows down dramatically right when an attack might be happening. To solve this, researchers created a new system called GraphFaaS. The key idea is to move away from fixed, rigid infrastructure to something much more flexible. They use a serverless architecture, which is a modern way of using cloud computing. Here's a simple analogy for how it works. Imagine a grocery store with a fixed number of checkout lanes. A serverless system is like a store that can magically open a new lane for every single customer that arrives and close it the second they leave. As shown in this diagram, GraphFaaS takes the massive workload, breaks it into thousands of tiny, manageable pieces, and has the cloud process them all in parallel. This elastic approach means it can instantly scale its power to match any workload, no matter how big or sudden. This ensures the system never gets bogged down. And the results are truly impressive. In this chart, the blue line represents the old, traditional approach, while the orange line is the new GraphFaaS system. You can see the baseline's detection time is all over the place, with huge spikes that mean it's getting overwhelmed and becoming very slow. In contrast, the orange line for GraphFaaS stays consistently low and stable. Putting numbers to it, GraphFaaS reduced the average detection latency by 85%, cutting it from over 14 seconds to just 2.1 seconds. It was also 64% more resilient, meaning its performance is far more predictable and reliable, even during those chaotic bursts of activity. Crucially, it achieves this speed boost without sacrificing any accuracy. So, let's recap the key takeaway. The problem is that sudden spikes in computer activity can cripple traditional intrusion detection systems, making them slow and unreliable. The solution proposed by GraphFaaS is to use an elastic, serverless design that dynamically scales resources to meet demand instantly. This leads to a system that is not only dramatically faster, but also far more consistent, which is critical for real-time threat response. This work paves the way for a new class of cybersecurity tools that can keep pace with the dynamic nature of modern cyberattacks, potentially stopping them before they can do any real harm.